is that in reality, chances are the analyzer is not functioning properly and requires maintenance. So that number might not even be true. This knowledge gap basically happens when the technicians get transferred to new departments before they are fully trained and they're fully mastering an analyzer, or if there are new inexperienced technicians, for example. Some of the technologies can also be more complicated, just the nature of a technology. Sometimes you need to be more knowledgeable, for example, working with the GC. Without the proper training, basically, the simple troubleshootings can be long and perhaps not successful. So unexpected excursions also can lead to problems where the analyzer requires servicing. For example, a GC, a gas chromatography system, just monitoring the BTU that experiences an excursion sometimes might require the entire gas to be replaced, depending on what the situation is. If you're working with a TDLAS, a tunable diode laser absorption spectroscopy, for example, so depending on what system you're using, again, if you go through an excursions and you're not well trained, you're not ready for that, it could be sometimes complicated depending on the case to solve the issue. Now, one of the most pressing issues faced by the biogas plant is also, so now what happens if my analyzer goes offline? The plant will need to flare or recycle the gas, which reduces the profits. So what if a sour event is happening, but there is no analyzer actually monitoring that strawberry inlet, for example? This can put the operator's safety at risk and again can lead to expensive impacts, as I mentioned. Now, everything, these are all serious challenges as mentioned, but everything I mentioned in terms of the issues and the problems with the analyzers and the parts and the lead time and service and all the support was the motivation for our team to start thinking about actually offering a package that includes all of these analyzers and solutions for all of the measurements relative to the biogas applications all together as a package. So by using basically specific manufacturers taking care of all the analyzer needs that you will have access to all the spare parts very quickly. We will have access to the engineer who is well trained to cover all of them at the same time at site. And basically makes it much easier and causes less trouble to deal with. Specifically in the situation that the world is going through right now, which is very hard, arranging a lot of supports just in nature. So also the design of the analyzers for this specific application is the way we've designed them. We've focused a lot on maximizing the uptime, which benefits from minimal hands-on maintenance and fast speed of response and a very good accuracy and great accuracy for the measurements. Now, if I want to put them all together, so basically we've made it possible again to get everything that you need in one package, and basically it's a one-stop shop. So what we offer in this package is the TDL for measuring H2S and CO2 and moisture. So that's the laser system or tunable diode laser absorption spectroscopy. You see it on the left side. We also have the tape system, the tape for measuring H2S and total sulfur. And we have a GC as well. And the GC is for the BTU and stream analysis. And that's what we are going to talk about a little bit in the next slides. Very quick theory. But then after that, we'll have the demo and Dave is going to walk us through. You will see how the units look like in the lab. Okay, so the Acula is a GPA, basically is a tunable diode laser absorption spectroscopy. It measures H2S and CO2 and the moisture, all of them in one single unit and one single area cell. So that's the beauty of this analyzer. All of the measurements are done with only one unit and one cell. You don't need to make it complicated, go to different analyzers to cover all the measurements or different cells more than one. There are no consumables at all for this analyzer. And the sensitivity is very, very low. So we basically go down to 0.15 ppm And that basically rivals tape without even needing any consumables. This makes Acula an ideal analyzer for this kind of applications for student gas outlet, for natural gas value chain, for biogas, and every similar application. So how that works is, very quickly, this is how the unit, basically the optics and sample cell of the Acula look like. You'll see them again in the demo as well. On the left side, we have the laser launcher in the cell window and detector. Underneath the cell, that's where the laser source and the heater and the pressure transducer as well as the vacuum pump are sitting. So very simple. In order to make the measurement, specific wavelength of the light has to be selected. So that's emitted by the laser. Basically what happens is that we adjust the current and the temperature of the laser emitter, and we get that wavelength, which is basically there's a light going now to the laser launcher and then gets focused, passes through the cell window, and then finally goes to the cell. So this cell here is a Harris cell. So what happens is there are two mirrors at both ends of the cell. So the light goes back and forth many, many times here. That's basically to increase the overall path length. So physically, this cell is 52.6 centimeters. The light goes back and forth in this design 100 times. So that's at the end, you will get 52.6 meters of the overall path length. And then after that, so during this process, the sample is absorbing the light. And then after the whole back and forth is done, basically the detector can tell us how much light is absorbed. And that's based on the spectroscopy is relevant to the concentration. So you can make the measurement and it tells you how much H2S or CO2 or anything you're interested in, you'll have in this sample. We do have the option for the sulfur inert as well for the very low concentration of the H2S to ensure a very good sample integrity as well. All right, so what you see here on the right side basically is a spectrum of the measurements. So first of all, we basically extract the sample by using a probe. We do have a sample system and this analyzer, so that basically includes the filters for removing any sort of particulates, any liquids that we do not want to send to the analyzer. At the end of the day, we make sure a sample is nice and clean and dry goes to the analyzer. We have the pressure regulator to regulate the pressure and making sure a good pressure goes to the analyzer, the way that analyzer makes the measurement. On the graph, what you see as a result, after all that absorption, you'll see that spectra. So what I want to highlight here is that, for example, if you focus on the H2S, you see a very sharp line here. It's not interfering with anything else, although we have some other gases in the background. H2S does not see them. Same thing happens for the other species as well. And the way we do it is we basically use a vacuum pump to make sure that we get this sharp and linear lines that are not suffering from overlaps from other species. And that's the way we use in the measurements. So basically it's an interference-free or matrix-independent measurement. And that's why we get a very good accuracy and very good sensitivity in this analyzer. So to give you a little bit more idea what I mean by that is, just in general, anytime we talk about a TTL, mostly people think about a direct measurement versus a differential method. So the direct is what we use, which is a vacuum pump. That technique does not require any consumable, it's direct measurement. And differential subtraction method, basically that's the one that people know mostly in our industry as scrubber. So you basically have a sample that has to be scrubbed and then also not scrubbed. So the difference between the two tells you how much H2S, for example, you have in the sample. So this one requires the replacement of that scrubber. The frequency depends on the application as well. So this is the main difference between the two methods. All right, so the IQLogic seats, this is how the unit looks like. You'll see the exact same thing during the demo as well. So that exceeds specifications for the natural gas at custody transfer. The analyzer operation is very flexible. It is compatible with VAC, VDC power. Maintenance for this analyzer is very, very limited. It's only every quarter we need to change the filters if there is a filter membrane, if there is any leak. And annually is just a replacement of the pump diaphragm, which is a matter of a couple $100. It's 5 minutes process, so almost no maintenance on this system. The vacuum pump is the reason, again, as I said, we don't need any consumables. That makes it almost no maintenance or maintenance-free analyzer. Now moving to the next analyzer, this one basically is a 903 tape analyzer. So what happens here is that we call it ProTech 903 as well. So that's a lead-acid tape measurement. So it's for measuring H2S as well as the total sulfur, depending on the application. We all come in one system, one unit. This analyzer offers the most sensitive H2S and total sulfur measurement available. It is basically used to monitor your inlet and outlet for the sulfur removal. So how does this analyzer work? Basically, the lead-acid tape method relies on the chemical reaction of the H2S with the lead acetate paper tape. So that's basically to form the PBS, which is the lead sulfide. So this appears as a brown stained color. So a concentration of the H2S and can be determined by analyzing the rate of this stain formation on the tape. So that's how we make this measurement. So a gas basically gas sample is humidified by passing it through a water permeable membrane. So that humidifies the gas and it can facilitate the reaction. Then after that, this humidified gas passes through a paper tape that, as I said, is basically lead-acid tape. So the amount of that gas that passes on the tape can be adjusted also. It is dependent on the size of the aperture strip. The tape is held firmly against the sample chamber by this compression head that you see down here. Then the H2S in the sample gas makes a reaction with that lead acid, and then that whole brown stain is formed. Then the light source can basically be used to illuminate the tape where the reaction is happening, and then the light detector is used basically to detect and tell us at the end of the day so how much H2S exists there. To give you a better picture of the whole flow diagram, so that's how it looks like. As you see, a sample comes in, passes through the humidifier, goes through this block here, it gets exposed to the lead acid tape, and right after that you see that so the measurement happens, and then it's vented basically afterwards. So again, as I mentioned in Acula, this unit, the tape also exists a specification for the natural gas at a cost transfer for the biogas and similar applications. Maintenance for this unit, depending on what we need to maintain. So on a monthly basis, we need to change out the tape. Again, the frequency for that can be reduced based on analysis frequency as well. As you see here, every 2 years, replacing that strip out every 3 years for the humidifier. So compared to Acula, more maintenance is required for this one. That's about tape. Now, the next one I wanted to quickly cover here is the AccuChrome. That's the GC unit, so gas chromatography, that uses a TCD, thermal conductivity detector. One analyzer here can handle up to 8 streams, which is great for complex operations. So the analyzer is certified for cost transfer applications. BTU and oxygen are the main ones considered here. Can be monitored in this system all in one. Now, AccuChrome GC acts as the specification for the natural gas at cost transfer as well. Maintenance is limited to a quarterly basis, and the overall design for this unit allows for easy access to components when performing the maintenance. All right. Now, everything that we mentioned altogether here, so all galvanic analyzers guarantee turnkey installations. We customize the sample conditioning, such as regulating the pressure, the flow, the filtration, all of that we can provide in a sample handling system. We also provide shelters with climate control when necessary, depending on where in the world this is going to be used. So for the cold weathers, hot weathers, if a shelter is required, we can provide that as well. Our sample system interfaces with all of our analyzers, which reduces the installation footprint as well. On top of that, we basically offer, as I was mentioning earlier, that on the support side, we offer local on-site services for all of our analyzers. This includes the startup, the PMs, the hands-on training. We can also help you from the factory point of view by performing the FATs. We also can remotely access your analyzers to facilitate the troubleshooting if that's what you prefer as well. So with this package, again, you will face the lowest cost of ownership for the full control of your entire measurement and analysis. Everything here can be measured in one single package. And interestingly, this unit is depending on where the sample point location is. So they can share the sample system as well. The package is totally a hands-off operation. It's very limited to no consumables, specifically when it comes to laser one. Remote analyzer access, no matrix dependency for the results, and there are all significant values that this package is offering. And again, I want to emphasize that the accuracy is very, very good accuracy, very low level measurements. So this all coming, it's not you're sacrificing one quality of the system to basically put them in a package. They all perform exactly as they do in a single unit. All right, so this was just a very quick theoretical background about this package and the application as well as this analyzer. So to sum up this theory side, Galvanic's core purpose is always to provide you with certainty. Our analyzers maximize the uptime to help you quickly identify the upsets. This automates the cost of transfer and avoids serious issues from occurring. We have been in this business for about 40 years. So we know the market, we know what's the specifications for each application and how to implement them in our analyzers and improve them to make sure that we meet your expectations. As you can imagine, being in this whole industry, so for about 4 years now in our business, so obviously we've done lots of different papers. One of them that I wanted to specifically mention here is the white paper that we presented at the Western Gas Measurement Short Course on this specific topic. So we shared our favorite learning moments to provide a guidance to future operations, basically. So if you have not read that one, I highly encourage you to have a look. And if you can find it, we'll be more than happy if you let us know to provide that to you. All right, so with that, I'm going to pass on to Dave now, who's going to walk us through the demo on these 3 analyzers. At the end of the demo, we'll be happy to discuss any questions that you might have. So Dave, I'm going to stop sharing my screen so you can share your site.
Okay, I'll just do a quick check with somebody on my team to let me know if you can hear me and if you can see the output of my camera.
I can see and I can hear you perfectly, Dave.
Excellent. Okay. Well, thank you very much, Parissa. That's great information. Good morning, everyone. My name is Dave Height. I'm the manager of product development here at Galvanic, and I'm going to spend a few minutes walking you through the 3 products that Parissa talked about in the presentation. The Acula's multi-component analyzer, And then we'll look at the ProTech H2S and total sulfur analyzer, and then we'll have a look at the AccuChrome GC. So what you're looking at on your screen right now is the Class 1 Division 1 version of Aculaze. The one that you saw in the presentation was also the Class 1 Division 2. Basically, what we're going to talk about here with this analyzer applies to both of the versions of it. It's just simply a difference in packaging between the two to meet the different hazardous area classifications. But we'll start here on the left-hand side. This is sample conditioning or sample entry here. So we have a sample entry here. It comes in through a Genie. That's a 123 membrane filter. So that filter is designed to take out any entrained liquids. It'll also remove particulate. There's a sweep that comes off of the bottom of that filter that can double as a fast loop, and it also sweeps away any liquids that might condense out in that filter. Pressure regulator with an inlet three-way valve for a calibration gas as well. That three-way valve can be replaced with a solenoid valve for automatic operation if desired. Typically, we'll set the pressure to the inlet of the analyzer at about 10 psi-G. It will then flow down into the this bottom part here. So what you're looking at here on the bottom, that gray sort of sheet there, that's basically an explosion-proof cylinder that houses the laser and the cell. And the gas is entering here through this metering valve in order to control the flow and the pressure in the cell. Parissa mentioned that we do rely on the reduced pressure in the cell to narrow the absorption peaks in order to eliminate interferences. And then once it goes through the cell, it just exits through this tube here and then out to a vent. That vent can be tied into either an atmospheric vent or a low pressure flare header in order to get rid of that, the gas that's passed through. So here we have the electronics enclosure. In this case, for the Class 1 Division 1, we've got the big heavy duty explosion proof type enclosure. Just have a quick peek inside to see the electronics mounted on the door. That's basically the CPU controller. You can see there's some connections there. There's USB connections, which are used internally. There's also 3 Ethernet connections, which can be used for networking the device for either remote access or for Modbus TCP/IP. Inside, then we have the power connections and various other customer connections. So up here we have the power input. Down here at the bottom, there's some 4 to 20 milliamp outputs. There's 4 of them and 4 relay contacts. And these can all be configured for either various streams or components, alarm enunciation. And all of this is also available through Modbus, either serially or through an Ethernet connection for Modbus TCP/IP. To